Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on exponential functions is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will review exponential expressions and the law of exponents. We will also be discussing exponential functions, graphing exponential functions, and solving exponential equations. An exponential expression is one of the form a to the r, where a is the base and a positive real number, and r is the exponent and is a rational number. An exponent describes a multiplication operation a times a times a, and so on, r number of times. If s, t, a, and b are real numbers, with a greater than 0 and b greater than 0, then the following laws of exponents apply. A to the s times a to the t equals a to the s plus t. A to the s taken to the power of t is equal to a to the s times t. A to the s over a to the t equals a to the s minus t. A times b to the s equals a to the s times b to the s. A to the negative s equals 1 over a to the s. 1 to the s equals 1. And a to the 0 equals 1. An exponential function is one of the form f of x is equal to c times a to the x power, where a is a positive real number and a is greater than 0, and a is not equal to 1. The constant c is a real number and not equal to 0. The domain of f is a set of all real numbers expressed as negative infinity to positive infinity in interval notation. Negative numbers for exponents create positive fractions, so the range of the exponential function is on the interval 0 to infinity, unless the negative constant changes the range. The base a is referred to as the growth factor. Since f of 0 equals c times a to the 0, which equals c, c is called the initial value. If a is greater than 1, then the function describes exponential growth. If a is between 0 and 1, then the function describes exponential decay. To graph exponential functions, we'll start with the basic function c times a to the x, where c is a constant term and a is the base. For the initial example, we'll use c equal to 1 and a equal to 2. 2 to the x has a domain from negative infinity to positive infinity, and a range from 0 to infinity. To graph 2 to the x, we'll use a set of ordered pairs. F of 0 equals 1, f of 1 equals 2, f of 2 equals 4, f of 3 equals 8. On the negative side, f of negative 1 equals 1/2, f of negative 2 equals 1/4, f of negative 3 equals 1/8. This makes 0 a horizontal asymptote of the function. We then connect the dots consistent with the known end behaviors and the domain and range. From this base graph, transformations can be made by shifting the graph. For example, 2 to the x plus 1 shifts the graph up by 1 and changes the range to 1 to infinity. Negative numbers here would conversely shift the graph down and change the range accordingly. 2 to the x plus 1 with the plus 1 in the exponent shifts the graph to the left. This action does not change the domain and range. Conversely, subtracting would shift the graph to the right. 3 times 2 to the x stretches the graph up by a factor of 3. Again, this action does not affect the domain and range. 2 to the negative x creates a reflection across the y-axis with no change to the domain and range. Negative 2 to the x creates a reflection across the x-axis and changes the range from negative infinity to 0. In a protected environment, the population P of a certain endangered species recovers over time, T in years, according to the following model. P of T equals 30 times 1.149 to the power of T. To find the initial population, we calculate P as 0, or 30 times 1.149 to the 0 power, which equals 30. To find the population after 5 years, we find P of 5, or 30 times 1.149 to the 5th power, which equals 30 times 2, or 60. The population after 10 years was found by solving P of 10. This equals 30 times 1.149 to the 10th power, or 30 times 4.01, or a population of approximately 120. The population after 20 years can be found by solving P of 20, or 30 times 1.149 to the 20th power, or 30 times 16.08, or a population of approximately 482. Many equations that describe nature and natural processes require an exponential function with the base as a certain irrational number symbolized by the letter e. The number e is defined as the limit of 1 plus 1 over n all to the power of n as n approaches infinity. E is a transcendental number approximately equal to 2.71828. An example of a natural process where e is the base of an exponential function is uninhibited growth and decay. A of t is equal to a sub 0 times e to the k times t, where a of t is the amount with respect to time, a sub 0 is the initial amount, k is the growth factor, and t is time. If k is a positive number, then the equation describes growth. If k is a negative number, then the equation describes decay. If the size p of a certain insect population at time t in days obeys the law of uninhibited growth, P of t equals 500 e to the 0.02 times t. What is the initial population? P of 0 equals 500 times e to the 0.02 times 0, which equals 500. What is the population after 10 days? P of 10 equals 500 times e to the 0.02 times 10, or approximately 611, rounded to the nearest whole number. Equations that contain terms that include a to the x, where a is greater than 0 and a is not equal to 1, can sometimes be solved using the laws of exponents and property. If a to the s equals a to the t, then s equals t. For example, solve the following. 2 to the x equals 16. 16 can be written as 2 to the 4th power. So 2 to the x equals 2 to the 4th, so x equals 4. 3 to the negative x equals 81. 81 can be written as 3 to the 4th power. So 3 to the negative x equals 3 to the 4th, so x equals negative 4. Lastly, e to the x squared equals e to the 3x times 1 over e squared. E to the 3x times 1 over e squared equals e to the 3x minus 2. This means x squared equals 3x minus 2. If we move all terms to the left side of the equation, it can be expressed as a quadratic equation, x squared minus 3x plus 2 equals 0. X squared minus 3x plus 2 factors into x minus 2 times x minus 1. Setting this equal to 0 leads to the two solutions, x equals 2 and x equals 1. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you and good luck with your studies.